here's what I want you guys to do. Just identifying key features right off the top, right? So the vertex, here I'll zoom in onto one. The vertex occurs at the very, very top of the parabola or bottom. Okay, it's the high or low point. Right. So if I were to identify that right off the top, maybe I'll use a highlighter. Vertex here is right here. Okay. What is that point? That's all you're talking about is it's a very specific point, right? You're going to say, okay, the point of that vertex is, okay, well, the x value, and remember all this stuff always follows x, y. Okay, so don't flip them. Be careful, right? X always goes first. Okay, well, how do I get to that point? I have to go to the left 1, which is negative, and then I have to go up 16. So left 1, up 16 is the vertex. Okay? The axis of symmetry is the equation of a vertical line that splits the parabola into two pieces. I don't even really want to use the dashes. I don't like them. Okay, it's the vertical line that splits the graph into two pieces. Equal pieces. Okay, which goes right there. Where does it occur? X equals -1. It's an equation. Okay, you're going to have to stay that it's an equation. Can you see that? Where'd it go? Oh. Okay. The optimal value. Okay, so most of us said, okay, we know what the optimal value is, which is great. Okay. We said, oh, okay, it's 16. Okay, well, it's not quite 16. Well, it is 16, but is it a maximum or a minimum at 16 is the question you need to decide, right? Remember, if this was a mountain, mountains look like this, right? You wouldn't have a minimum on a mountain, right? You'd have a maximum or a peak, right? So that's specifically what I'm looking for. You're looking to say there's a maximum of 16. When does the maximum occur? When x equals -1. It's a verbal representation of your vertex. Okay? And I suppose the only tricky part is deciding, like, how you're going to, is it a maximum or a minimum? Is the only tricky part, really. Okay? Most of us were good. It's frowning. Okay? So we're going to say down. And I suppose, just for yourselves, you could say frown. I'm just writing like a list. Down, max. Smile, up, min. Okay, that's I suppose you're going to start here. You're going to look at a graph. You're going to say, okay, it's frowning. It's opening down. There's a maximum. Okay, doesn't change. Oops. Oh boy. There's something underneath. It's titled wrong underneath there. I don't want to show it. Okay. It says Formative 6 on it. It's not Formative 6. Okay. Then you're saying, okay, this is the other part that everybody's kind of, and I said this was going to happen, and nobody listened apparently. X-intercepts. Everybody's good. We're saying, okay, they're at -5 and +3. And then we go down here, we go -5 and 3. What is that? That looks like a point to me, right? Where I'm going to go to the graph and I'm going to plot -5 and 3. I don't know what that is, aside from one single point. That's not what it is. It's zeros, plural. Needs to be 2 of them. All right, well, how is that different than what I wrote? You need to write it like this. The x, if these are 2 points, one is here and one is here. You need to tell me what both these points are in terms of value. Well, one of them is at -5 and 0, and the other one is at 3, 0. Okay, they need to be 2 distinct points, and I said that in the lesson, okay? Otherwise, it just looks like one point floating somewhere up on the grid somewhere. Doesn't mean anything. Okay? Same thing with the y-intercept. Most people are good. Okay, we know what the y-intercept is. It crosses there. But can't just say 15. I don't know what that is. Okay? Y-intercept is a point. Specifically, it is a point where the x value is 0. And what do you get when you plug the x value of 0 into the equation? That is what you need for the y-intercept. Okay, if you were to read off this point, its value would be 0, 15. That's what I want to see. Okay. Anybody have any questions just before I move on? That's my thought process. So as I'm typing your comments there, if something doesn't make sense there, just think back to the solution. Okay. Okay. Now, everybody's progressing quite well towards this question down below. Okay, this is not, you saw how easy it was to make an error. And this is why, this is exactly why we don't like to produce graphs this way. Okay. This is why we don't necessarily like y equals ax squared plus bx plus c. We want it in y equals ax minus a number times x minus a number. Okay, that's why we like this. Because this is annoying. And it's unfortunate that's the only way to really produce a graph from this form. Okay, which is why we teach you factoring to write it like this. So that you don't have to do all of this. Okay, I don't want to do this. You don't want to do this. You have to because it's in the curriculum, right? But past this is not the most efficient way to do this, which is why we show you factoring. Okay, so you can see how easy, you saw how easy it was to make a mistake. It's just too easy, which is why we don't like it. Okay. But most of us are actually progressing quite well towards, you just got to be more careful is all, right? And I think the neater you are in terms of, I try to give you as much space as I can, but I think the neater you are in terms of writing each step out, the less likely it is you're going to make an error, okay? And so when we do this, right, I write out everything. Minus 4 times negative 2 plus 4, okay. Let's do the next line. Well, negative 2 squared is 4. Negative 4 times negative 2 is positive 8 plus 4. 4 plus 8 plus 4, 16. There's your first point. Okay? Just got to be careful. Can't I just do this? I won't make it so that there's 10 points here for you to do, but 5 seems reasonable. Okay? So plug in the next one. Negative 1 squared minus 4 times negative 1 plus 4. Well, negative 1 squared is 1. Negative 4 times negative 1, positive 4 plus 4. That's equal to 9. Okay, next one. 0 squared minus 4 times 0 plus 4. 0 squared is 0. Negative 4 times 0 is 0 plus 4. Okay. 1 squared minus 4 times 1 plus 4. 1 squared is 1. Minus 4 times 1 is minus 4 plus 4. That should equal 1. And the last one, 2 squared minus 4 times 2 plus 4. That's 4 minus 8 plus 4. Okay, that'll be equal to 0. Okay, just gotta be careful, and I try to be careful. Like, I don't know, it's very easy to make a mistake, very easy, particularly with a sign. So you just gotta be careful. I write out every step, and then I know if I'm right or wrong using the next step. Okay. Remember, this is our first differences, and these are our second differences. If these don't match, if these are not all the same, you've done something wrong. The same would be true as if you have some kink in your graph, right, where there's like something like this, and then then you know you're wrong. Something's happened. Okay, this should be a nice curve. So you're using these little clues to see if you're right or wrong. Okay, if I were to do the first differences on these, I'm going to see that 16 minus 9 should be 7. 9 minus 4 is 5. 4 minus 1 is 3. And 1 minus 0 is 1. Okay? I can see kind of a pattern going on there, right? In the first differences. See how this thing's changing. Well, if I do the second differences, I'm going to see 7 minus 5 is 2. 5 minus 3 is 2. 3 minus 1 is 2. These all match. I know I'm right. Okay? That's your first clue that you're right, if those match. If they don't match, you've done something wrong. So 1 point or 2 points or all of them are out of whack, right? But the next clue would be, okay, if I can go over to my graph and I can plot these points where there's an input. Remember, I'm plotting inputs versus outputs, right? Along the y. Okay? So, you're going to have a red piece and a blue piece, and you're just going to go plot these points. Negative 2, 16 is right here. Negative 1 and 9 is right here. 0 and 4 is there. 1 and 1. And 0 and 2. All right. What do we have? And I commented on this too on some of your tests. Or actually, on all your quizzes if you produced the graph. Okay. I know that you know because I taught it to you, or at least you're in the progress of learning it. There's an axis of symmetry. I know you know that. Okay. If you have an axis of symmetry, there better be an equal area on this other side. Well, how do I get an equal area is your question. And this is the question I posed to you guys in your comments was, can you produce the other half of the parabola? Yes, you can. How far is this point away from the axis of symmetry? It's 1 away. So I'm going to count 1 away and plot it there. How far is this point away? 2 away. How far from here to here? 3. How far from here to here? 4. All right, and it's at the same height. It's not going to draw its line. Okay, that's it. You can see I don't want to do that. You don't want to do that, right? I'd prefer if you guys could factor that. Factor this and then graph it. Like that's what I showed you today, right? I'd prefer you to be able to do that, right? This is tedious, easy to make a mistake. And for what? To get the same result. So why wouldn't you choose the method that is faster and less likely to make a mistake on, right? Why wouldn't you do that? Is it a little bit of work to figure out the process? Yeah, absolutely, right? It's the same thing with substitution, right? Okay, there's a better way to do things. This is the better way. It's to graph using the other equation, the factor form version, okay? This is just a way. It's an introductory way, okay? So if anybody have any questions? Okay, it's 1:35. You have now sat through the solution to